In a lab setting, it's rarely having a reaction go to completion. You usually have things in excess, and you usually have something that's limited, meaning that you don't have enough of it. This could be due to many instances from environmental or even from human error. So today I'm going to talk about the limiting reactant. What that is it's the reactant that is going to limit the others from completion of the reaction. We can actually predict this without going to the lab. And I'm going to show you from this behind me. It's very, very simple. It's two little ratios. For the first balancing equation, I have silicon oxide with 4 moles of HF. That is going to yield SiF4 plus 2H2O. The first thing we want to do is we have to look at the problem and what's given. In the problem, we have 6 moles of HF, and we also have 4.5 moles of SiO2. We want to know which one's limiting. So we have to set up two ratios. The first ratio, I'm just going to start here. We have 6 moles of HF, and we just simple ratio. We have 1 mole of HF, that should be a 4, from the balanced equation, and up here we have 1 mole of SiF4. Again, where I got these numbers is in the balanced equation. These numbers here are stated inside the problem. We set up a simple ratio between what we have and our product, which is SiF4. The numbers again came from my balanced equation. I have 4 moles of HF, and I have 1 mole of SiF4. This answer will yield 1.5 moles. We have to do this again now with the other moles of SiO2. This one, we have 4.5 moles. This is a new ratio, so we're not using the HF. We still have the same product. Now we have to figure out what these ratios are. Well, the product is still the same, so it's still going to be 1, but now we have to look at the SiO2. In this case, it is also 1. These cancel out, so our answer will still be 4.5. 1.5 is going to be the smaller of the two values, so therefore HF is going to be the limiting reagent. So let's try another problem, and then I'll have you work on your own. You can try an example in the book. Methanol is the simplest of alcohols. It's made between carbon dioxide and hydrogen. Carbon dioxide is a gas plus hydrogen yields CH3OH. This is methanol. We want to know what is going to be the limiting reagent when we have 500 moles of carbon monoxide as well as 750 moles of hydrogen gas. Should be carbon monoxide right there. So we have 500 moles of CO, and then we also have 750 moles of H2. Just by looking at this, we can't tell which one is going to be limited. You have to go through the ratios in order to find that out. So in the first one, I'm going to start off with carbon monoxide. Set my ratio up. We have, I'm putting this on the wrong side. What is my ratio? Actually, this one's balanced. Now it's balanced. We have a 1-to-1 ratio, and my answer will be 500. So we have one answer. Now we need to go to the second one. So let's do 750 moles of H2. Still, we're going to have the methanol on top. Now again, we have to look at the ratios. We have 1 up here, which is stated, and then we also have 2 down here. In this case, my answer is going to be 375. Out of the 2, which one is going to be the least? It is going to be the hydrogen. So therefore, hydrogen, or the hydrogen gas, is going to be the limiting reactant. Well, how much or maximum amount of methanol can be made? It's the least value. which is 375. You need hydrogen in order to make the methanol. If you only have 375 of it, you can only make the highest value of methanol is 375. This is also your limiting reagent. That is it on limiting reagents. Hope you guys have questions for tomorrow in class that we can go over some examples.